Good evening friends, study with the Pala Engineering and General Geology Parvin Singh. So our next video on metamorphic rock. So इसकी जो मेटासोमेटिक कंडीशन है मेटासोमेटिज्म उसको हम रीड करेंगे. It may be broadly defined as a metamorphic process involving essentially formations of new minerals by the mechanism of a chemical replacement of pre-existing mineral under the influence of chemically active fluids. The metasomatic replacement of minerals take place at atomic levels and in solid state. The chemically active fluids may be provided from within the rocks such as pores, fluids, in which case the end result of metasomatic change would be mere displace of the atoms. The total chemical composition of the rocks remaining the same. This is sometimes referred as minerals metasomatism. From outside the rocks and such as from magmatic emanations or groundwater sources is in which case many new minerals may be forced in the rocks by the interactions of the atoms of the invading fluids with those of the rocks. The net result would be definite change in the bulk chemical composition of the rock as a whole. This is therefore sometimes referred as rock metasomatism. The process of metasomatism is sometimes further distinguished into hydrothermals when the fluids are in the forms of solution, pneumatalytics when the fluids are in the forms of gases or vapors, additive when the net result of the process is additions of a new constituent, and expulsive when some component get removed from the original composition of the rocks. A common fact observed in the case of metasomatism is that the total volume of the rock remains by and large unchanged after the process is completed. Further, the change can take place over a wide range of temperature and pressures, and like others, metamorphic processes are completely essentially in solid state. Metasomatism is quite common in silicate and carbonate rocks. Effect of metamorphism. A variety of change may be caused in pre-existing rock subjected to metamorphic process. This depends primarily on following two major factors. This type of rock involved in the process, the kinds of metamorphic process operating on those rocks. Generally speaking, the metamorphic process may result in one or more of the following main categories of effect on the involved rocks: crystallizations, rocks fluids, granulations, and metasomatic replacement. Recrystallizations, all the change in the direction of mineralogical reconstitutions and structural patterns of rocks during the process of metamorphism are collectively expressed by the term recrystallizations. This process involved simultaneous growth of new crystals from the existing ones by atomic constructing. Due to rise in temperatures with or without a concurrent rise in pressures, but facilitated by pore fluids. In most cases, the change takes place essentially in a solid state. This effect is most notable in the rocks adjoining the magmatic intrusions or those coming in contact with lava flows. In such cases, the following conditions control the extent of recrystallizations. The size of the igneous intrusions. The size of the igneous intrusions or the lava flows which served as the source of heat, the initial temperature of the magma or lavas, and also its rate of cooling. The higher the initial temperatures, the greater is the effect. Against the slower the rate of cooling, greater is the degree of recrystallization. So the nature of magma or lava. Magmatic melts rich in chemically active fluids will induce a greater degree of recrystallization. as compared with those which are poor or free from these fluids. The nature of rocks, it is the single most important factor in that the same rock under different condition may suffer different set of change during the process of recrystallization. Chemical composition and original texture define the susceptibility of a rock to recrystallizations and rock flows. By rock flows is understood actual movement and reorientations of the minerals constituent of rock under the influence of fluids acting during the metamorphic process. The terms should not be taken to give the impression that rocks change their physical state from solid to liquid and start flowing when subjected to pressure. So rock flows is simply the slippage of the grains or crystals essentially in solid state, making them orient themselves in such a way as not to offer any further resistance to the applied forces. This may result in flattening or minerals constituents and there's gliding over and one another's and development of peculiar structures like rocks, cleavage and foliations. Rock flows is believed to be a common process at a greater depth and near the roofs and the wall of magmatic boundaries and also along the margins of tectonic plates. Granulations, sometimes under the influence of dominant stress rocks develop granulations, which signifies the birth of very fine fractures within the body of rocks involving even the individuals minerals. The pressures being of confining types, the minerals fragments bound by these fractures retains their solidity in the natural state. But as soon as the rock is removed from its original place and a little pressure applied in crumbles into fragments, example insist granulations is favored by hard and insoluble character of the constituent minerals as well as by higher confining pressure. Metasomatic replacement. Metasomatism, as already defined, is essentially the process of simultaneous replacement at atomic levels by which minerals of rocks are changed into other minerals by additions or subtractions of atoms under the influence of chemically active fluids from the surroundings environment. Silicate and carbonate rocks are easily altered by metasomatic change in the process. The process may involve exchange of additions to or expulsions of metallic or non-metallic compounds from an original rock. Thus, it may be alkalis metasomatism, sulfur metasomatism, and so on. So, once the attacking fluids are in vaporous state, the process is distinguished as a pneumatolytic metasomatism or simply as a pneumatolysis, and vapors of waters, borons, fluorines, and many alkalis metals emanating from the magmatic bodies take active parts in changing the mineralogical compositions of rocks surrounding these bodies. Thus, the granites attacks successfully by water vapor in combinations with borons and fluorines gas may suffer a mineralogical change whereby original feldspar. एग्जाम्पल KLSI3O8 ये फेल्सपार का फार्मूला है and may get partially or completely changed into a new minerals tourmaline, borosilicates of alumina. The originals granite rock is changed metasomatically into a tourmalines granites when the replacement is only partially. Example, some feldspar is still left unchanged or into a scorls rocks when also the feldspars of a granite is changed into tourmaline. And similarly, when the granite rock is attacked by streams of fluorines and vapors, only the feldspars are altered to lithium micas and the new rock is called gracine. And this metasomatic change is sometimes termed as a gracining. Kaolinization is another such a process where feldspar are converted to kaolin. Under the influence of streams, vapors, and dolomitization is a metasomatic conversion of limestone into dolomite, CMG, CO3 whole twice in the presence of magnesium ion rich solution. So example of metamorphic change. Metamorphic process cannot be either observed directly or demonstrated practically. They are very gradual, large-scale processes involving geological time measurables in terms of millions of years. It is only through the study of their effects on the rocks that conclusions can be drawn regarding the nature of the process through which those rocks have passed. And different rock behaves differently under given condition of metamorphism. Metamorphic effect on many different types of rocks exposed in different areas of the world have been studied in sufficient details by many petrologists. It will be practically impossible to present even a summary of such a change in these books, and many excellent references are available on metamorphic petrology. The following examples indicates only the trends of change observed in some common rock types as illustrations. Igneous rock. So acid igneous rock. These rocks are rich in free silicas in the forms of quartz, SiO2s, and granite is a typical example of this group of igneous rocks. And granite are generally very hard and resistant rocks. They are affected only slightly under normal metamorphic conditions, but when the degree of metamorphism is very high, quite a few new types of rocks are formed from granite. Under condition of dynamic metamorphism, granites are simply broken and crushed, forming a newly structured rock called crushed breccias. In other case, the hard minerals of granite like quartz and feldspars may be flattened and elongated under the imposed loads so that ultimately they remain embedded in the finally crushed grouped ground masses produced due to crushings of other minerals of granite. Such metamorphosed granite are called feldspar granite. Similar change may be produced in gabbros and other coarse grained igneous rock. In many cases, the crushing effect due to imposed loads may be practically completely involving all the constituents. Such extremely crushed metamorphic rocks are described as myelonite, and contact metamorphism of granite involves most commonly the simple recrystallization of the constituent minerals. In regional metamorphism, however, when the heat factors is actively associated with pressure and chemically active fluids, granites and others dilated or igneous rocks so very considerable and conspicuous change, they may pass through a flexuous rocks type stage under the influence of a directed stress and suffers a simultaneous and substantial recrystallization due to intense heatings and interplays of chemically active fluids. The net result may be a new foliated coarse grained rock called granites. Basic igneous rock. So formation of new minerals and impositions of new texture and structures are major changes shown by basic igneous rocks that have been subjected to metamorphism. Under contact metamorphism, only mineralogical reconstitution is observed. So while the original texture and structure are retained, rocks like gabbros and dolerites having suffered such a change as described as meta-gabbros and meta-dolerites. Under dynamothermal regional metamorphism, however complex mineralogical change are associated with the development of foliations, crushings and granulations of mineralogical constituent. Rock like gneisses and cysts of great varieties are produced. Hornblende, cyst and amphibolite are a few important examples. Thank you.